Hello, and welcome back to Bioclass Bytes. In this video, we are going to talk about exogenic processes. Don't forget to subscribe to my channel and like and share this video. These are the unit and lesson titles for this video series, and in this video, we are going to focus on exogenic processes. Exogenic processes fall under this unit on geomorphic processes. We define those as physical processes which create and modify landforms on the surface of the earth. It could be exogenic, exo meaning external origin, just like the sun here, or endogenic, endo within, internal origin. So those refers to the sources of the Earth's internal heat. Geomorphology is the studies the landforms that pattern Earth's surfaces and the processes that shape them. Okay, so geomorphic processes will be the overall lesson of this entire unit. From the term geo meaning Earth, and then morph forms, so forms of the Earth. The formation and deformation of landforms on the surface of the Earth are considered continuous processes, which is due to the continuous influence of external and internal forces. If we could still remember our lesson on the rock cycle, we have established there that all those rock cycles could take hundreds, thousands, millions, even billions of years as they transform from one rock to another. So same thing here with geomorphic processes. The internal and external forces causing stress and chemical action bring about all these changes on the surface of the Earth. I recommend that you watch this video entitled Physical Geography: Forces That Shape Our Earth. I will provide the link in the description below. So this will be our guide for this entire unit. So geomorphic processes or earth formations, earth movements are categorized into two major parts. Exogenic processes, those processes wherein the origin of the changes are external, and endogenic processes wherein the origin of those processes comes from within the earth. So in this video, we will focus mostly on exogenic processes, specifically weathering, erosion, and deposition. So under weathering, these are the different types of weathering: physical weathering, chemical, and biological weathering. So this refers to the breakdown of earth materials. Erosion, on the other hand, is the transport of those broken pieces, either through running water, groundwater, glaciers, waves and currents, and winds. And deposition is the settling down of those broken down and transported earth particles, still through running water, groundwater, glaciers, wave currents, and winds. So we have established that exogenic processes are earth processes wherein the origin or the force comes externally. So the source of those the driving force of all those processes would be the sun, specifically the sunlight. Sunlight causes air to move, water to be lifted into mountains, and ocean waves to rise. So for exogenic processes, the source or the driving force of energy would be the sun. So these moving fluids attack solid surface, erode it, carry the broken pieces away, and deposit them to fill low places in the landscape. In other words, we can define exogenic processes as mountain destroying. They break down mountains, they break down huge chunks of rocks into smaller particles. For example, here at a dust storm. So wind erosion is one example of exogenic processes. So the wind there, the formation of the wind or the creation of the windstorm is actually caused by sunlight, as it causes air to move along the atmosphere. So all the exogenic processes are covered under the general term denudation. So to strip, nude, to strip or uncover. It is the long-term some processes that cause the wearing away of the Earth's surface, caused by the following: ice, water, winds, and waves. So this results into the destruction, destruction of elevation, reduction in elevation and relief, or deformation of landforms and landscapes. So let's look first into weathering and erosion. So we define weathering as the breakdown of Earth landforms, and erosion is the process of transport of those broken pieces. I recommend that you watch this video, Weathering and Erosion, from Crash Course Kids. I will provide the link in the description below. I also recommend that you visit this website from National Geographic, which talks a lot about weathering, different samples, and different images. Again, I will provide the link in the description below. So we define weathering as the breakdown or dissolving of rocks and minerals on the surface of the earth. So weather, to break down. So the agents of weathering, or the ones that cause this breakdown, are water, ice, acid, salt, plants and animals, and even changes in temperature. Here are some everyday examples of weathering. So weathering processes are responsible for the deterioration of objects and materials on Earth's surface. So we can see weathering causing the deterioration of paint on this wood siding, and we can see here a stone structure, possibly marble, that eventually succumbs to weathering processes and become deteriorated over time. We can also see plant roots breaking or tree roots breaking concrete and rock, okay, as the roots spread underneath the cement. Potholes, okay, on roads are especially common in places that experience wintry, okay, winter or wintry condition, or in our case here in the Philippines, where when we experience a lot of rain, okay, rainy season. They contribute to pavement destruction. Chemical weathering processes also, such as oxidation, is responsible for the formation of rust on cars like this. Into the two main types of weathering, physical and chemical weathering. So physical weathering refers to the disintegration or disaggregation of rocks by physically breaking them apart. So mechanical weathering or physical weathering, they refer to the same thing, while chemical weathering refers to the decomposition of rocks because of chemical reactions, and it alters them to become new substances. So these are examples of physical or mechanical weathering. So again, this is the reduction of rock or destruction of rock without chemical alterations. So this includes frost action or mechanical. This happens when mechanical force is exerted on the rocks by freezing the water in the rock pores. So for example here, so if this is your rock, and then when it rains, water becomes collected on the rock crack, then should there be a drop in temperature, or when it becomes a winter time, water freezes and expands, forcing the crack to widen. And then when spring comes or summer comes, the ice will thaw, and then water will eventually evaporate. And then because of that, the water gets deeper into the crack, and then when it evaporates, it will cause the rock to crack until it splits and then eventually disintegrates. Next would be exfoliation. The rock surfaces on deserts face extreme variation in day and night, causing the outer layers of the rock to peel away. So exfoliate, the removal of the upper layers, such as this one, and then this one, the slow disintegration of the upper layers because of varying temperature. And then biotic factors, root systems of plants can grow in between the cracks or crevices of rocks, and then eventually it will pry them open. It will attack the lines of weaknesses of the rocks, and then eventually they will break down. We see here an example of exfoliation in an igneous rock. So before the igneous rock was formed beneath the surface of the earth, but due to uplift, it was being pushed upward. It became eventually exposed on the earth's surface, wherein weathering could take action on it. And we see here the summit of Half Dome in California Yosemite National Park. This one is a very good example of exfoliation. As you can see, the layers covering the dome is being exfoliated or removed like onion layers, okay, through sheeting. We're familiar with frost wedging. Okay, so for example, if you leave a glass of bottle in the freezer a bit too long, you will find the bottle fractured. The bottle breaks because liquid water has the unique property of expanding up to 9%, okay, upon freezing. So this is why when you put bottle of beverages in the freezer, eventually it would explode and break apart because water expands when frozen. Okay, so we can also expect the same thing to happen when there's frost wedging in rocks or land formations, okay, on mountains. So during winter, the snow enters the crevices of these rock formations, and during the cold season, cold winter, the snow eventually expands, causing the rock to break. And eventually, bit by bit, year by year, in a course of hundreds and thousands and hundred thousands of years, that will cause the weathering and erosion of that rock formation. Chemical weathering, on the other hand, alters the chemical and mineral composition of rocks. For example, in terms of solution, many minerals dissolve in water, forming weak acids, in turn dissolve rock minerals like carbonates and such. Okay, so we have here an example of chemical weathering. So as you can see, these cracks or this part of the rocks were actually disintegrated because of the reaction of weak acids in rainwater reacting with the calcium carbonate found in rocks. So it results to rock being dissolved and then cracks to expand. Um, so here we have another example of chemical weathering. So this statue, possibly containing calcium carbonate, eventually become weathered down, and as you can see here, the features are no longer visible after um, 60 years because the weak acid in the rain have had chemical reactions with the calcium carbonate, causing them to erode this way. And then oxidation is the reaction of oxygen in air or water with the minerals in the rocks. So in iron-rich rocks, usually given discoloration, causes rusting, leading to the crumbling of these rocks. And then decomposition by organic acids, bacteria in the soil or or mosses and lichens on rocks produce acids which eventually dissolve in water and hasten the weathering of the underlying rocks. We see here a good example of chemical weathering, acidic waters that can create caves. So the dissolving power of carbonic acid is important in creating limestone caverns such as this one. Okay, so the chemical reaction eventually carve out the mountain and carve out the inner portions or interior of the mountain to create such caves. Another evidence of chemical weathering is the colorful rock formations. Okay, so many sedimentary rocks, as we can see here, very familiar with the layers of sedimentary rocks, are colorful because pigments, okay, came from small amounts of iron oxide. Okay, so rocks such as hematite produce orange, red, and pink hues as seen here in the red rocky country in Sedona, Arizona. Now this shows us the formation of rounded boulders as water penetrates the rocks. Okay, so water creeps into the crevices, then chemical weathering decomposes the minerals. Okay, minerals within those rocks. Okay, possibly dissolving calcium carbonate from the acidic rainwater. Then eventually the rocks will break apart, and then eventually they will after hundreds and thousands and millions of years they will end up into a more smooth surface. Okay, so they could start out with a very rough angular rock here at this point, but weathering attacks the corner, especially the corner of the rocks, to create a more smooth a smoother shape like this. Then eventually over time, they could be rounded up into something like this. Another major type of weathering is biological weathering. Here, plants and animals are the ones contributing to weathering of rocks and rock formations. For example, plant roots or tree roots can actually physically break or wedge in between the rocks, causing them to fall apart. Lichens, so that's a symbiotic relationship between algae and fungi, such as this one, can actually remove materials and weaken the rock they are standing on top of, or they are growing on top of, by releasing the acids brought about by their biological processes. And burrowing animals such as weasels and some worms can actually increase weathering of certain rocks. So together, these three are the major exogenic forces um, that actually affect and break down landforms. So weathering, that's the physical breakdown of substances such as rocks and minerals through physical, chemical, or biological processes. So once the rocks have been broken down, they can be transported or carried on to a new location. We call that erosion, or movement of sediment or soil from one location to another, brought about by agents of erosion such as wind, waves, and water. And finally, once they reach a new destination, they are when they're carried to the other location, we call that deposition. So still, water, ice, and wind play important role in those processes. So do not forget that exogenic forces derive their strength outside the Earth's exterior, or from the Earth's exterior. So usually that's the sun, because the sun is responsible for wind by heating up air and then all those wind processes. The sun is also responsible for wave formation, and of course for water cycle. The sun plays an important role in that. So again, these are the exogenic processes. It starts with weathering, breaking down, then transport through erosion, and then deposition, settling down on their new location. So because of these three processes, exogenic forces are mainly called land wearing. They wear down, they break down land wearing forces. So you see here more agents of erosion. For example, water erosion. So severe sheet erosion on farmland, as seen by the movement of bodies of water. Wind erosion, as seen here in massive dust storm. And glacial erosion, as the glaciers melt and they travel downwards or towards bodies of water, they bring with them certain rock particles and rock materials. So wind erosion is an exogenic process because as the wind blows, um, certain particles detach and it also transport those soil particles. Then erosion by rain also, or water erosions. So through the process of evaporation as part of the water cycle, and then glacial erosion, still an example of exogenic force, because when the temperature increases, the glaciers would melt and then they would travel downwards or downstream, taking with them those soil particles. So this help us visualize how weathering, erosion, and deposition happens. So the weathering occurs on the rock formation, mountains, facades of mountains. So weathering loosens the quartz grain from the granite, from the rock formation. Then eventually rain or snow, okay, so will erode and wash the uh, quartz grain, okay, downwards. Okay, the stream in rivers or streams transport the quartz grain down the slope, then eventually it's deposited into the sea. Okay, so deposited or washed out into the sea. So this is how weathering, erosion, and deposition happens um, in nature. How do human activities accelerate soil erosion? So activities such as farming and conversion of forests into ranches are actually huge factors that accelerate soil erosion. So I recommend that you watch this video, Soil Erosion Around the World, causes and solution, I will provide the link in the description below. These images show us drastic changes in the environment. Okay, it shows tropical deforestation in western Brazil. So as you can see, the green parts of the map are the heavily forested areas, while the light brown parts are the deforested areas or cleared areas. Okay, so clearing the tropical rainforest is a serious environmental issue, and we all know that it can actually accelerate soil erosion since plants are biotic factors that hold on or keep the soil intact. So if you remove the plants and the trees that keep the soil intact, then the soil will become looser. It will be easier for rain to carry and carry them into other areas or to erode them to other areas. So deforestation is human activity that accelerates soil erosion. I also recommend that you watch this video, Desertification. Again, the link in the description below. So here, the video will talk about how the conversion of forests into farms are actually results into desertification, or the creation of more and more deserts, more and more dry regions of the world. So now that we're done with weathering and erosion, now let's look into the last exogenic process, deposition. So that is when the sediments or when the rock particles have been carried to their new location through running water, groundwater, glaciers, waves and currents, and winds. So deposition is the geological process in which sediments, rocks, and soil are added to a landform or land mass. So again, these are the agents of deposition. So they transport previously eroded. So what comes before deposition is erosion. So after they are transported, they will now settle on their new location. So they build up layers and layers of sediments in their new location. So I hope you still remember the lesson on the rock cycle. One good way to visualize the relationship between erosion and deposition is through visualizing how rivers meander or how rivers curve. So meandering, the curving of rivers. So as you can see here, on that part wherein there's a body of water that's actually touching this part of land, going in this direction. This is where mostly the new materials are deposited. While those part on the outer part of the river, wherein there's rapid movement of water, that's where erosion happens. So on the slow segments, the slow part of the river, inner part of the river, that's where deposition happens. On the outer part of the river, stronger currents, that's where erosion happens. Okay, so as you can see here, so this used to be the flow of the river in this curve pattern, but sooner or later, because of the curving, because of the cutoff, eventually these two sides of the river eventually met. So so what happens here? Water cuts through the bend and created a new path here. So this part will be detached from the river, okay, since the water will no longer flow here, and we call this an oxbow lake. So here again, water was supposed to travel in this path. However, because of the bending of the river at this point, water just happens to merge with this pathway, and then it does not flow here anymore. So it goes directly to the nearest pathway, cutting this off and then creating another oxbow lake. We can see oxbow lake. So here, for example, here, if these two parts of the river eventually connects, then this part will now be an oxbow lake. Okay, so that in that way. So if this part of the river eventually connects, this part will now be an oxbow lake, like that. Okay, so it used to bend that way, but since they're now very close, the river just decided to cut off from this side and then to just continue. So to cut off from this side and then just continue, creating an oxbow lake here. So I've mentioned a while ago, the innermost part of the river is actually where the deposition happens, while the outer part of the river, where there's a stronger current, that is where erosion happens. So you can see the arrow here, it points to us where the fast current is. So here, erosion happens because that's where the fast current is. But here on this side, there's slow current, so there's deposition here. Then faster current, again erosion here, deposition here, faster current here, so erosion here, deposition here. So that's how rivers meander, that's how they curve. But this does not happen overnight. This happens over hundreds, decades, up to hundreds, up to thousands of years. So these are examples of a meandering river. Okay, I recommend that you watch this video. This is actually a time lapse of how and why rivers curve. I will provide the link in the description below. So in this segment, as you can see, the river is actually on its way to merging. So sooner or later, these two parts of the river will merge, and this will become a new oxbow lake. So if ever that this part of the river connects in this way, the river meanders this way, so this part will connect, and then this will become another oxbow lake. So I recommend that you watch this video. Very, very informative. That ends our video. I hope you learned something new. Don't forget to subscribe to my channel and like and share this video. Till next time, goodbye.